We'll be presenting about the determination of a xenobiotic in food sample through reduced sample preparation coupled to multidimensional chromatography. Mariosimone, the floor is yours.
Good morning, everyone. Thank you, KTH, for the introduction. I would like to thank all of you for the very nice conferences. Today, I show you 3 different applications. Probably some of you already know the first one because I already presented part of this one in the previous meeting. However, just to show you the evolution of our approach. So I show you 3 different methods for the analysis of phthalates in vegetable oil and pesticides in extra virgin olive oil and also in hemp seeds oil. Nowadays, the trend is to move to greener chemistry, green analytical chemistry, and greener sample preparation. The analytical chemistry has 2 different and contradictory rules sometimes because we need to evaluate the environmental impact of some components and also the human health of some components, generating other hazardous substances and things sometimes, and also high volume of wastes. So our approach in order to reduce, in order to develop greener method is to reduce the sample preparation because we are chromatographers, so I cannot renunciate at any extra dimension. So this is the only way. We already, all of us know the main advantages of using GC and GC. In this case, probably the best thing is the enhanced sensitivity compared to 1D run and also the enhanced selectivity. Then we couple with a TRIPLE-QUADRUPOLE, so a selective detector. I know it could seem a strange definition because we are going to define a very highly informative techniques with a selective detector, but in this case, the enhanced sensitivity of both of them, the separation side and the detector side, will help us to increase the sensitivity and thus reducing the sample preparation, thus the extraction and the concentration of the analytes. The first approach, it was very simple. Starting, give you some information regarding the samples, the extra virgin olive oil. These are very important food products, especially for Italy, because there are a lot of healthy, good reasons to have a very good extra virgin olive oil. Regarding the production, it is obtained only using mechanical process, starting from milling, pressing, and so on. Something on the composition. For sure, the composition is almost 100% saponifiable fraction, that's triglycerides. For sure, you are aware that triglycerides are difficult to analyze using GC techniques. So if you need to analyze some xenobiotics like phthalates or pesticides, you need to do extraction in order to remove triglyceride before of the injection. Something very fast regarding phthalates, they are esters coming from the phthalic acids. They are used in mainly to increase the plastic softness, the flexibility, and they are divided according to the length of the chain of the chain. So we have both low and high molecular weight PAH. Something regarding the analytical approach, starting from the injection side. Injection probably is one of the most important things using this kind of approach. We decided to use a direct column injection using an empty liner in order to avoid any carryover, because packaging inside of the liner, if you inject at high temperature, can cause the degradation of triglycerides and so causing a very high carryover. Regarding the analytical column, we employed a quite short column, only 10 meters, with a thin stationary phase in order to easily allow the elution of the triglycerides. And something regarding the sample prep, only dilution. So we diluted 10 milligrams of extra virgin olive oil in 1 ml of solvent. This is the MRM chromatogram of a spiked extra virgin olive oil with all the phthalates present in European legislation. As you can observe, a very high selective method and without any kind of interference. So obviously the quantification of these components was quite easy. And as you can observe, also the accuracy and the precision are very high due to the fact that the sample preparation is negligible. To be honest, the limit of detection for this kind of contaminants, according to the EU, is not very low. Thus can be considered quite simple approach. As you can observe, the BBP limit from food contact is 30 ppm. So we decided to move to a quite challenging approach, so the analysis of pesticides. Regarding the legislation, there are more than 500 pesticides present in the European limits, and the maximum residual limits in this case is lower, starting from 5 ppb for some of them. Thus, after a look on the literature, almost all the scientists employed SP extraction or catcher's extraction before to do this kind of analysis, generating a quite high amount of solvent, for sure higher than 10 ml. Unfortunately, using the direct injection, we were not able to reach the 5 ppb level, so we did a very small extraction using only 500 microliter of acetonitrile and 500 milligrams of sample, and then we injected 4 microliter of the upper phase. The configuration is the same that we employed before, so nothing new, only the injection volume. It was a little bit higher, 4 microliter instead of 2. And here it's how chromatograms look like. So in this case, you can see 70 pesticides are 0.4 ppm level. Now I would like to show you some figure of merits. I know that it's a little bit boring, but I think that this only way to convince scientists to move GC from research to routine analysis. Something regarding recovery, in this case, GC is not the point. The recovery depends on, of course, of the log P of our pesticides, and of course, in this case, due to the broad range of components, recovery it's in a very big range, starting from 15 up to 120%, more or less. In this case, the European legislation puts some restriction. If your recovery it is outside 70 to 120%, your accuracy must be very good. And as I show you in a while, in this case, the accuracy for sure is quite good because we did only a simple liquid-liquid extraction. And as you can observe, the accuracy is between 80-40 and 100% more or less. We also did some tests in a long term, so within intermediate precision condition without using new stock solution. And as you can observe, the results are in very good agreement. Something regarding the matrix effect, it was very strange for us after a first look that all the analytes gave us a positive matrix effect ranging from more or less 10 up to 200, close to 100%. Really, also in this case, this behavior could be explained by the presence of high boiling compound inside of our acetonitrile extract, thus the triglyceride, acting as analyte protectant, thus avoid the interaction with active sites present in the analytical column into the line, and thus increasing the signal of our components. Few results regarding the analysis of real samples. We analyzed 20 samples, and unfortunately, few of them present a level of pesticides higher of the maximum residual limits. Something a little bit different, MC oil, it could seem similar samples. We increased the number of pesticides, close to 197 to be precise. The production is very similar to the extra virgin olive oil one. The composition also is quite similar, a presence of high amount of polyunsaturated fatty acid. This is the reason why they are now almost called superfoods. In this case, we take a look at different legislation, the European one, the Canadian one, and the California. You can see that there are totally different number of pesticides allowed. Also, the maximum residual limit is totally different. So in this case, we need to achieve also a very broad linear range. Here again, the chromatogram, also in this case, 97 pesticides detected in a quite easy way without interference and obtaining good results. Of course, again, the recovery in this case only show you at 0.5 ppm for time reasons. And again, the accuracy, it is very good, between 84 and 110%, so within the limit of the European limits. Something a little bit different, matrix effect. In this case, we calculated a totally different behavior. In this case, as you can observe, we have a 50-50%, starting from minus 100 and plus 150. So we decided to go a little bit deeper into the total ion chromatogram of the two samples. Oh, something happened to the chromatograms. In any case, in the upper side, you can see the extra virgin olive oil chromatograms. In the lower side, the MC oil. As you can observe, in the first case, in the extra virgin olive oil, the total ion chromatogram, it is almost not overloaded with components, with big amount of components, but spread along the entire chromatogram. In the case of the MC oil, you can see a very big amount, very big peak in the middle of the chromatogram with a higher intensity compared to the extra virgin olive oil. In this case, these big components is the free fatty acid, the linolenic free fatty acid that cause ion suppression inside of the ion source. In fact, the components with a negative matrix effect are eluting exactly in that area of the chromatogram. Something regarding real samples analysis, we analyzed 10 MC oils, and also in this case, unfortunately, there are components with a very high amount, amount inside of the samples. In conclusion, the use of GC GC was demonstrated because you do not need any kind of sample extraction in the first case. In the second case, you don't need any kind of cleanup. The sample preparation was minimized, thus increasing, of course, the accuracy, reducing the wastes and the time. I would like also to give you some numbers regarding the robustness of the method. We did 350 analysis considering phthalates and pesticides without any need to clean the ion source. We changed the analytical column after 350 analysis, but you have to take in mind that we employed only 10 meters of the column, thus only 1/3 of a conventional GC column. I would like to thank my research group and also Shimazu and Mer for the support. And of course, thank you for the attention.